How long do you think it takes to build a skyscraper? 2 years? 3 years, perhaps? Now imagine if it took only 19 days. It sounds like science fiction, but it's a reality that unfolded in China, and it's changing the way we think about building the cities of tomorrow. In the next few moments, you'll discover the extraordinary story behind Mini Sky City, a 57-story skyscraper erected in less than 3 weeks. We'll uncover the secrets behind China's modular construction revolution, examine the technology pioneered by the Broad Group, and discuss what this means for urbanization around the world. From the nuts and bolts of modular engineering to its global implications, join us as we explore how one project may have just rewritten the rulebook for city building. Let's start with the foundations, both literally and figuratively. The centerpiece of this story is Mini Sky City, a remarkable building that towers 57 stories above the bustling city of Changsha in China's Hunan province. This isn't a skyline you'd typically associate with rapid-fire construction, but it's here that Broad Sustainable Building, or BSB, achieved what many believed was impossible. Their mission? To meet the urgent demands of China's rapidly urbanizing population with a solution that's not only fast and affordable, but also environmentally conscious. So why was Mini Sky City built? It's more than just a feat of engineering. China's urban population has been growing at a staggering rate, creating immense pressure to provide safe, affordable, and sustainable housing. Traditional construction methods can be slow, expensive, and environmentally taxing. BSB set out to prove that there was a better way, a method that could produce high-rise buildings in record time, at lower cost, and with a drastically reduced environmental footprint. Mini Sky City wasn't just a building, it was a proof of concept, a bold statement that the future of construction could be radically different. But how exactly did they do it? How is it possible to build a skyscraper in less time than it takes to plan a wedding? The answer lies in the revolutionary modular building system at the heart of Broad Group's technology. Instead of constructing each floor from scratch on site, the vast majority of the building's components were fabricated in a factory under tightly controlled conditions. These pieces, including steel frames, integrated wall panels, plumbing, and electrical systems, were then transported to the construction site, where they were assembled like an enormous three-dimensional puzzle. This approach transforms the very nature of construction. Imagine that instead of baking a cake from scratch in your kitchen, you received pre-baked layers and pre-made frosting. All you have to do is stack and decorate. That's the essence of modular construction. For Mini Sky City, the precision and speed came from the use of CNC, or computer numerical control, cutting machines. These automated tools cut and shaped materials to exact specifications, ensuring that every piece fit perfectly. The core structure was a prefabricated steel skeleton, designed for rapid assembly, with wall panels that slotted effortlessly into place. Each day, the construction team could add up to 3 new floors, a pace unheard of in traditional building. But speed is only part of the story. Modular construction also means that much of the labor-intensive, error-prone work happens in the factory, where conditions are safer and more predictable. On-site, the focus shifts to logistics and assembly, drastically reducing the number of workers needed and minimizing disruption to the surrounding area. This level of planning and pre-production is what enabled such an astonishing build rate. Now, let's dive deeper into the technology and innovation that make this system not just fast, but also sustainable and safe. One of the boldest claims about Mini Sky City is its energy efficiency. It uses up to 80% less energy than a conventional building of similar size. How is this achieved? The secret lies in advanced insulation materials, triple-glazed windows, and an integrated systems approach that optimizes heating, cooling, and lighting. The building's envelope is designed to minimize energy loss, while smart systems regulate temperature and maximize natural light. Sustainability doesn't stop at energy use. The materials themselves are chosen for their low environmental impact, with a focus on recyclability and reduced carbon emissions during production. Factory fabrication also means less waste. Components are made to measure, so there's minimal leftover material. Even the assembly process is greener. With fewer trucks, less heavy machinery, and lower on-site emissions, the environmental footprint shrinks dramatically. Safety is another area where Mini Sky City sets new standards. The entire structure was rigorously tested for earthquake resistance and is rated to withstand a magnitude 9 earthquake. In a country where seismic activity poses a real threat to urban centers, this level of resilience is critical. But safety isn't just about withstanding the elements, it's also about the health of the people inside. Mini Sky City incorporates an advanced air purification system, ensuring that indoor air is up to 20 times cleaner than what's typically found outside. In cities where pollution is a serious concern, this is more than a luxury, it's a necessity. Now, how does this all compare to traditional construction methods? Under conventional approaches, a project like Mini Sky City would take at least 2 years, often longer. The process would involve dozens of subcontractors, unpredictable weather delays, and mountains of waste. Labor costs would soar and the environmental toll would be significant, with heavy machinery running for months on end. In contrast, BSB's modular approach slashed the timeline to just 19 days for on-site assembly, with the majority of work handled in advance at the factory. This isn't just a matter of speed. The reduction in labor hours translates directly into cost savings, making high-quality urban housing more affordable. Fewer workers on site means less risk of accidents, and the compressed schedule minimizes the impact on neighbors and local businesses. When you compare the timelines, costs, and environmental impacts side by side, the advantages of modular construction become clear. It's not just about building faster, it's about building smarter. Of course, no innovation comes without controversy. Some critics argue that rapid construction must come at the expense of quality. Can a building assembled in less than a month really be as durable and comfortable as one built over several years? Others worry that modular buildings are inherently less attractive, that the focus on efficiency leads to a loss of architectural diversity and character. If every city were filled with identical prefabricated towers, would we lose the unique charm that defines urban life? And what about culture? Should every city follow China's example, or are there lessons to be learned from different approaches to urban development? It's a debate that goes beyond bricks and mortar. At its core, it's about what kind of cities we want to live in and what we value most: speed, cost, sustainability, or individuality. For some, the modular model is a bold step toward solving the world's housing crisis. For others, it's a cautionary tale about the risks of prioritizing efficiency over quality. Looking beyond China, the implications of this technology are vast. In rapidly developing regions like India, Africa, and the Middle East, the demand for affordable, resilient housing is urgent and growing. Modular construction offers a way to meet this demand at scale, potentially transforming entire cities in a fraction of the time required by traditional methods. Imagine slums replaced with safe, energy-efficient homes, disaster-stricken areas rebuilt in weeks instead of years. But why hasn't this approach taken off to the same extent in Europe or the United States? The answer lies in a complex web of regulations, labor practices, and cultural preferences. In many Western countries, construction is slower, more expensive, and highly regulated. There's also a greater emphasis on customization and architectural heritage, which can make standardized modular systems a tougher sell. Yet, as housing shortages mount and environmental concerns grow, the tide may be turning. Some analysts have even compared the rise of modular construction to the impact Tesla had on the automotive industry, a disruptive force that challenges old assumptions and opens the door to new possibilities. So what does this all mean for the future of urbanization? Mini Sky City is more than just a building. It's a new way of thinking about how we create the spaces where we live, work, and connect. It's a vision of cities that are not only built faster and more affordably, but are also healthier, safer, and more sustainable. It challenges us to reimagine what's possible, to ask not just how quickly we can build, but how well we can build for the generations to come. But there's an important question at the heart of this transformation. Are these rapidly constructed buildings truly livable, or do they come with hidden risks? Is the trade-off between speed and quality worth it? Would you feel comfortable living in a skyscraper that rose from the ground in just under 3 weeks? Or is there something about the slower, more traditional approach that gives us confidence in the places we call home? As we stand at the crossroads of a new era in construction, these are questions each of us will have to consider. One thing is certain: the story of Mini Sky City is just the beginning. As more cities grapple with the challenges of urbanization, climate change, and economic inequality, the lessons learned in Changsha may shape the skylines of the future. If you found this exploration of modular skyscrapers fascinating, there's so much more to discover. Consider subscribing to stay updated on the latest breakthroughs in architecture, engineering, and urban design. And if you're curious about the future of smart cities, green building technologies, or other innovations reshaping our world, check out our other deep dives into the topics that matter most. So, what do you think? Is the age of ultra-fast skyscraper construction upon us? Or are there still lessons to be learned from the past? Let us know your thoughts. Can you imagine living in a building constructed in just 19 days? Or would you prefer the reassurance of a slower, more traditional build? The future of our cities may depend on how we answer these questions together.